Hi guys, we're going to talk about decision analysis. We always make decisions in our lives, but the question is, what is involved in making a good decision? So for this topic, we will mainly talk about decision theory and about the tools that would help us make the best decisions, not only even for business, but also for the other aspects of our lives. Decision theory is an analytic and systematic approach to the study of decision making. And also, according to this, a good decision is one that is based on logic. It considers all available data and possible alternatives and applies a quantitative approach. So, with this decision analysis topic, we will learn how to make a good and sound decision using statistics. And also, this avoids any biases from emotions, from peer pressure, etc. So for example, if you're a lumber company planning to expand, what would be the best alternative course of action? So let us say your alternatives are to construct a large plant, construct a small plant, or do nothing. So let us find out what are the different methods that we can use. So there are 6 steps in decision making. Step 1, you have to define the problem. So for this particular example, the problem is to consider expanding by manufacturing and marketing a new product or backyard storage sheds. This is for the Thompson Lumber Company example. And for the step 2, we need to list down all of the alternatives, or these could be the options that you are thinking of to resolve the problem. So number 1 is to construct a large new plant. Second is to construct a small new plant. And third, do not develop the new product line. Now, if you have all of the possible options listed, we go to step 3, and that is to identify the possible outcomes or states of nature. Now, states of nature are things that you cannot control, like for example, how the economy will work. So it could be favorable or unfavorable. So for this one, the market could be favorable or unfavorable. But of course, states of nature are not limited to only these 2 things. Just remember that for alternatives, they are options that you can control. You can add more to it or not include certain options. While states of nature, the term nature itself there, these are things that you have no direct control over, but still they're going to happen whether you like it or not. But of course, sometimes we do not have the certainty of what will actually happen, just like, for example, whether it's going to be sunny or rainy. Even though there are forecasts, there's no certainty that it will actually happen. So that's kind of like states of nature. Step 4, list the payoffs. Identify conditional values for the profits for large plant, small plant, and no development for the 2 possible market conditions. This is called conditional values because these values will depend on which alternative you chose and which states of nature will happen. And the payoffs, the term payoff itself, are basically what you expect to receive from that particular alternative in a particular states of nature. Step 5, select the decision model. Depends on the environment and amount of risk and uncertainty. Later on, we will discuss what the decision model is or what these methods are that will help you choose the best decision or best alternative. Step 6, apply the model to the data, which means that this is the part when you actually get to compute. And so the results from this computation will help you determine the best decision. Just to illustrate it better for you, again, the problem is to consider expanding by manufacturing and marketing a new product, which are backyard storage sheds. The second step is to list down all of the alternatives which we see here on the left side of the table. Third step, list down the states of nature. So for the states of nature, these are the columns on the right side of the table. And for this one, we have favorable market and unfavorable market. Step 4 is to list down the payoffs or the conditional values. And notice that we have different values corresponding to a particular alternative and a particular state of nature. So for example, for first alternative, construct a large plant, and for a favorable market, there is a conditional value or a payoff of $200,000. However, if you only construct a small plant in a favorable market, you'll only receive $100,000. So there are different types of decision-making environments. One is decision-making under certainty. So as you can see here on screen, the decision maker knows with certainty the consequences of every alternative or decision choice. So it becomes easier for the person to choose something or to choose an alternative because they know what would be the consequences right after. So it's very clear for them. For second, decision making under uncertainty, the decision maker does not know the probabilities of the various outcomes. And in the decision making under uncertainty, with the term uncertainty, you're not quite sure about what will come out or what will be the result of your decisions. So later on, we will be learning how to make decisions under uncertainty and how we make use of the different values to compute for the best alternative. And last would be the decision making under risk. The decision maker knows the probabilities of the various outcomes. So basically, these are the major differences. It would be more on the probabilities. For decision making under uncertainty, there's 100% that you already know what's going to happen. For decision making under uncertainty, you have no idea what the probabilities are, but you might have the values to help you compute for the best alternative. And the last one is that you know the probabilities for the various outcomes. All right, so now we talk about decision making under uncertainty, and there are different models that we can use and apply to our problem or the problem we're working on. First is the MINIMAX, which is also called an optimistic approach. Second, MAXIMIN, which is also called the pessimistic approach. We have criterion of realism or HURWICZ. We also have equally likely or LAPLACE, and last but not the least would be the MINIMAX regret. So the first thing, MAXIMAX approach or the optimistic approach. It is called MAXIMAX because you are basically going to choose the maximum out of all the maximum. That's why it's MAXIMAX. And since it only looks at the maximum values, this is why we call it optimistic. So it only looks at the best out of all the best. So the way to do it is you have to look at each of the alternative. So how you do it is that you look at each of the alternative and look at the maximum payoff for each alternative. For example, when you construct a large plant, there are two possible payoffs. One is $200,000 and the second is a negative $180,000. So between the two, $200,000 versus negative $180,000, which would be the higher payoff? So of course, we have $200,000. For constructing a small plant, there are two options. We have $100,000 and a negative $20,000. Between the two, of course, we know that the positive $100,000 is higher than the other, so we choose $100,000. As for do nothing, since you're not going to do anything at all, you do not expect any outcome or payoff, so it's just zero. Now, all of the values that we've chosen per alternative, we write it on the right side of the table. And now we have here the maximum in a row. Now, out of all these maximums, we choose the maximum number. And you already see here that $200,000 is our MAXIMAX or the maximum out of all the maximum. Again, look at each alternative and choose the maximum payoff for each alternative, and then select the maximum out of all the maximum payoffs. And whatever MAXIMAX you've selected, that would be the alternative that you've chosen. So that is optimistic approach. Now we have the pessimistic approach, which is also called the maximin criterion. Maximin because you're going to choose the maximum number out of all the minimums in a row. And this is called a pessimistic because you're only going to consider the minimum numbers. But of course, we're not too pessimistic enough that we're only going to choose the minimum out of the minimums. It means that you are expecting for a worst possible scenario out of all the alternatives, and despite this worst possible scenarios, which would be a better choice for you. All right, so we follow the same flow as earlier. We'll look at each of the alternative. So let's start with the construct a large plant between 200,000 and negative 180,000, which would be the minimum number. So we get negative $180,000, and we put it on the right side of the table under the label minimum in a row. Next alternative, construct a small plant, and we are working on two values. We have $100,000 versus negative $20,000, which would be the minimum number. Of course, we choose a negative $20,000. And as for do nothing, we just get a zero all throughout. Now, we have different values here under the minimum in a row. We have negative $180,000, we have negative $20,000, and a zero. Now, out of all these values, which would be the maximum? So since 0 is greater than a negative, we choose 0, and 0 is our maximin. Now, since 0 is the payoff that we've chosen, this corresponds to the alternative do nothing. And so for a pessimistic approach, the option or the alternative to choose is to do nothing. Now we go to criterion of realism. So for criterion of realism, or HURWICZ, this is also called the weighted average because we're going to incorporate the best in a row and the worst in a row. And it's going to incorporate the coefficient of realism, which is the alpha. It's also interesting because alpha, as we've studied before, is the symbol for type 1 error. So for this one, we're going to add this element to add a bit of a realism or that type 1 error into our computation. And since we are going to incorporate best in a row and worst in a row, if alpha is equal to 1, then it is a perfectly optimistic formula. Because if you can see in the formula below that when alpha is equal to 1, the worst in a row gets multiplied to a 0 because 1 minus alpha or 1 minus 1 is equal to 0. And what is left would be the best in a row. If alpha is equal to 0, it is perfectly pessimistic because it means that the best in a row will be multiplied to a 0 alpha. And you are left with 1 times the worst in a row. So you need to remember that so that it will be easier for you to make computations in your mind depending on the alpha that is assigned or you will want to assign. Now, next would be to compute the weighted average for each alternative and select the alternative with the highest value. So remember that this formula will be computed per alternative, and you're going to choose the maximum number out of all the computed averages. Now let's start with this one. So for constructing a new large plant, we have 200,000 and then a negative 180,000. Let's say that the alpha is equal to 0.8. So look at the formula below. We have 0.8 times $200,000 plus 1 minus 0.8 multiplied by negative $180,000. So this ultimately gives you the number $124,000. If you construct a small plant, you have 0.8 times 100,000 plus 1 minus 0.8 times negative $20,000, and this will give you the answer $76,000. As for do nothing, of course, it's just 0. Now, we have the values for the criterion of realism. For construct a large plant, we have $124,000. For construct a small plant, we have $76,000. And for do nothing, it's 0. Now, out of all these values, which would be the maximum number? And so we have $124,000, which corresponds to the alternative, construct a large plant. Now, based on this model, criterion of realism, we choose to construct a large plant. Now, next model would be equally likely or LAPLACE. This considers all payoffs for each alternative. And how do you do this? You get the average payoff for each alternative. Now, for example, in alternative 1, construct a large plant, you get the average between the favorable market payoff and the unfavorable market payoff. So we get a 200,000 plus negative 180,000, which gives you $20,000, and then you divide it to the number of payoffs in that row, which is 2. So $20,000 divided by 2 gives you a row average of $10,000. Now, for constructing a large plant, we have $100,000 plus negative $20,000. It gives you $80,000 divided by 2, and you get $40,000. And as for do nothing, that's just 0. Now, we looked at all the row averages, and now we have 10,000, 40,000, and 0. Out of all the averages here, which is the highest number? And so we have 40,000 as the highest number, which corresponds to the alternative, construct a small plant. Last model would be the MINIMAX regret. So the term opportunity loss, this would be what you would have lost or what would have cost you if you chose this instead of the other options. And so there are different steps on how to do it. Number 1, create an opportunity loss table by determining the opportunity loss from not choosing the best alternative. All right, so how you do this opportunity loss table would be you choose the highest number per row. This is already the opportunity loss table, but we are going to base our first computations on the original table. Now, for example, for this one, we know that $200,000 would be the payoff for the first alternative, and 0 would be the payoff for the third alternative. And for the opportunity loss table, what you do is to identify the highest number per state of nature. And this highest number will become the value wherein you subtract each of the payoff per alternative for each row. So for example, in the favorable market, the highest number is $200,000. Now you're going to use that as the value from which you subtract the other payoffs. So for the first alternative, that will be a 200 minus 200 because they are both the highest numbers. For the second alternative, that is a 200,000 minus $100,000. And for the last alternative, that would be 200,000 minus 0. Later on, we will see the results for this one. And then for unfavorable market, it's still the same thing. You choose the highest number and you use it as a value in which you subtract the payoffs from. So the same goes that you choose the highest number from which each of the payoffs are subtracted. So for the unfavorable market, 0 would be the highest number. And so 0 minus negative 180,000. And then for second alternative, that's 0 minus negative $20,000. And then third is 0 minus 0. All right, so now we have this opportunity loss. And now you see here that how the values have changed. Now the favorable market, since earlier for the construct a large plant, it was 200 minus 200. Now you get a 0. And then construct a small plant is 100,000 left because it was 200 minus 100. While do nothing, that will be 200 minus 100. So what does this mean? It means that in a favorable market, if you construct a large plant, then you would have lost $0. That is the opportunity loss for not choosing the others. So of course it's 0 because it is the best option available. For do nothing, you would have made an opportunity loss of $200 because you did nothing. instead of constructing a large plant that could have given you a payoff of $200,000. Now, for the unfavorable market, if you chose to construct a large plant, that would have made you lose $180,000 as opposed to doing nothing, because it is an unfavorable market. Now, since it is called minimax regret, you're going to choose the minimum out of the maximum possible alternatives that may cause you regret, basically. So we will first choose the maximum per row. This is more like a pessimistic approach that you're thinking of what would be the maximum opportunity loss for me for each alternative. Now for the first alternative, constructing a large plant, 0 versus 180,000, we choose the maximum in a row, and that is 180,000. For construct a small plant, we have 100,000 versus $20,000. We choose the highest number, which is $100,000. For do nothing, we have $200,000 versus 0. We choose the highest, which is $200,000. Now we have all of the maximums in a row listed. We have 180,000, 100,000, and 200,000. Out of all these maximums, we choose for the minimum, or the minimum out of all the maximums. And so we choose $100,000. It means that it will provide you, or it will give you, the least opportunity loss out of all the other alternatives if you choose this alternative over the other alternatives. So that's it for the different models for decision making under uncertainty. Again, we had MAXIMAX, or optimistic approach, which basically means choosing the maximum out of all the maximums. MAXIMIN approach, or pessimistic, which means choosing the maximum number out of all the minimum numbers. We also have criterion of realism, wherein we incorporate the coefficient of realism, which is alpha. We also have equally likely, or LAPLACE, which means that you need to get the average per alternative and choose the highest or the best values out of all those averages. And we have the minimax regret, which is choosing the minimum number out of all the maximum values that would possibly make you regret, or basically it revolves around opportunity loss. So that's it for the different models for decision making under uncertainty.